This is part 3 of our video on proofs. And in this part, we are going to look at some trigonometric proofs. Now, you'll notice here, we have some things on the side that we haven't really talked about yet. So these are called trig identities, and they are some relationships between sine, cos, and tan, secant, cosecant, and cotan that are true. So they're true relationships between those functions. Now, these can be found on your green package in the section of reciprocal identities and quotient identities. There are other identities. There's Pythagorean. Actually, we're going to look at the first one in the Pythagorean. We've got related angle, correlated angle, and the compound angle at the bottom. Until we prove all of these, we are not using them. The only ones we are using today are the ones for cosecant, secant, and cotan, tan and cotan, and the very first one in the Pythagorean, which is the sine squared plus cos squared equals 1. Those are the 6 identities that we are going to be working with today. None of the other ones on our sheet are currently available to us because we have not proven where they come from. Okay, so here are my 6 rules. One of them really is just about cotan, that cotan is 1 over tan, and since tan is sine over cos, it's cos over sine. So you may have seen these in grade 11, you may not, right? I'm not going to ask you to memorize them, they are on our green sheet. In grade 11, your teacher probably should have proven at least the first 2 on the list to you, and if not, you can ask me sometime and I'll show you. All right, so we're going to take a look at the question that says prove that cosecant x times cosine x equals cotan x. So what we want to do is take one side and see if we can find a way to manipulate it to turn it into the other side. So I'm going to start maybe just by separating my left side and right side. Left side is cosecant x. Now, when we've been doing trig, we've been using a bracket around the arguments, but when I'm doing proofs, a lot of times we don't put the bracket just because it's a lot of extra writing. So I'm just going to write cosecant x, but if you want to put that extra bracket in, go for it. And then cos x. Oh, and see, out of habit, I went to do the bracket. All right, cosecant x times cos x. There we go. And then my right-hand side is cotan x. Now, there aren't really a lot of operations happening here. We've got some multiplication on the left side, and then we just have one function on the right-hand side. So there's a couple of things that I try to do when I'm dealing with a trig identity. And the very first one that I find is often successful, not always, but often, is to try to write everything in terms of sine and cos. So I am going to make a little note underneath here that one of my go-to strategies is to try to write the terms using sine and cos. Right? So that means if I have a cosecant or a secant, I would write them as 1 over sine or 1 over cos. If I have a tan, I'm going to do sine over cos. If I have cotan, I'm going to do cos over sine. I'm going to try to write everything that I can in terms of sine and cos. So I think I might start on the left-hand side just because there's 2 things versus just 1. So it looks like there's a little bit more that I can do here. Cosecant, I want to try to write in terms of sine and cos. So cosecant is 1 over sine x. And then cosine x is already a cosine, right? We said we're going to try to write it as sine and cos. It's already a cos. So I'm going to multiply by cos x. And I'm going to use brackets to show that, to keep everything organized. Now, a lot of this is fraction operations, right? How do I multiply 2 fractions together? We do top times top, bottom times bottom. What is underneath that cosine of x? A secret one. So I would do 1 times cos x. Well, 1 times cos x is cos x. And then sine x times 1 times sine x is sine x. Now, from here, once I've finished doing whatever operation I do, I have choices. I can go work on the other side, or I can try to stick to this side. Now, I would recommend, once you've written things in terms of sine and cos, used the fraction operations to follow it through, I would look to see, does this match an identity? Does it match the other side? Is there something we can do with it? Now, cos x over sine x, if I look over here, is the same thing as cotan x. So this equals cotan x, meaning my left side equals my right side. If you want to add the QED, which is what we had to prove, do it. And if not, that's okay. You can just write left side equals right side. All right, and that does it for our very first trigonometric proof.